Hi everyone. Today we are revisiting one of our favorite topics from geometry, and that is the unit circle. Now, regardless on your opinions on the unit circle, I promise you that you will feel better about it this year than you did last year because it is your second time seeing it. I'm really not teaching you anything new. I'm not teaching you anything beyond what you learned last year with the unit circle. I am going to teach it all from scratch as though you've never seen it before, but seeing it for a second time and already having that exposure is going to make it so much easier this time around. So before you get started, you may want some different colored pens or pencils to be able to fill in your unit circle. This should be located in your notebook for you. You can always draw one too if you want to. And do feel free to pause the video at any time. I am going to speed it up in some different sections just so you don't have to sit and watch me do all the writing. But if it's going too fast for you, feel free to slow it down. So just let's talk about the basics of the unit circle. So what the unit circle is it's basically just a circle with a radius of 1, okay? And so this right here is like the center of a coordinate plane, like this would be 0, 0, the origin, and this is 1 unit in each direction, okay? So the coordinates right here, this is the origin, right? So the coordinates right here would be 1, 0. And then if I were to go up 1, this would be 0, 1. Over here would be -1, 0. And down here would be 0, -1. Okay. And then all these other dots, we're going to find some coordinates for those in just a minute too, but we've got to do some trig for that. So we'll get there. The reason the unit circle is significant is we can use it to find trig values for angles that are bigger than 90 degrees. All the triangles or all the trig we've done so far has been inside of a right triangle, and so you can never have an angle that's bigger than 90, but you can do trigonometry with angles bigger than 90, and that's what the unit circle lets you do. So here's how the unit circle works, and actually I wish I had a marker for this, but we always start our measuring from this line right here. And this is considered to be like 0 degrees. Okay, so we're always starting from here. And so if we're calling this 0 degrees, a turn up to this line would be a 90-degree angle. Do you agree that this angle right here would be 90 degrees? So I'm going to label this up here 90. Okay, and again, that really comes from the fact that this angle down here is 90, but if we label all our angles down here in the center, this middle is going to get really messy. So we're going to label our angles out here, even though we're really talking about angles down here. Okay, if I were to go from this here, 0 degrees, all the way over to here, that's 180 degrees, correct? That's a straight line. So this would be 180. And then I can go 3/4 of the way around, which really adds another 90 onto that 180. And so this down here is 270 degrees. Okay, kind of hard to see there, but that's 270. And then if I go all the way around, so I'm talking about like from this line and spinning all the way around to here, that would be 360 degrees. Okay. One other quick thing we want to make sure we understand about how things work on the unit circle before we go to filling in all these other points is how these angles are measured. So you'll notice that I was moving in this direction as I was counting off my angles. So I did 90 degrees counterclockwise, okay? Moving in this direction is how positive angles work, okay? So our positive degrees go this way. You will also hear me sometimes refer to like a -90-degree angle, which sounds weird when you're thinking about like angles and triangles and things like that. But -90 degrees just means that I'm moving in this direction. So -90 would actually be the same thing as 270, okay? And so one of the ways, and I'll come back to this when we do some examples, but anywhere you're standing on the circle, if I'm standing here and I add 360 degrees, I'm going to move 360 degrees and land right back in that same spot. So if I took -90 and added 360 to it, I'm going to come out at that 270. So if you're ever confused about what a negative angle is, you can always add 360 to it to try to make it positive so you can figure out where it's at. We're going to talk about some other tricks with negative angles also, but wanted to make sure those directions made sense. The one other thing that I should throw in real quick is, like we said, this is like a regular coordinate plane, right? This is like 0, 0. And then we've got our x-axis and our y-axis, all right? On a coordinate plane, this quadrant here, all of our values are positive, right? X is positive, y is positive. So in this quadrant, all of the coordinates we label are going to be positive. When I go over here, my x's are going to turn negative, right? This is moving in the negative direction. That's why this is a -1. But my y values up here are still positive, okay? So these are going to be negative x values with positive y values. Down here, I have negative x's and negative y's. So these would all be negative. And then going down here, I've got positive x's with negative y's. So that would be positive, negative. That shouldn't be new information for you. Okay, you should understand how that works on a coordinate plane, but you may want to go ahead and sketch it on this paper just so it makes sense as we go around and start labeling all those other coordinates. Okay, as far as these dots in the middle, before we get to those, we need to revisit a topic from geometry. And this next part, I don't know that you necessarily need to write down, okay, just follow along with me so that you can get a handle on where these values are coming from. So you may remember in geometry, we did special right triangles. We did the 45, 45, 90 triangle and the 30, 60, 90 triangle. When we learned about these triangles, we learned that their sides always fall in a very distinct pattern. Specifically in the 45, 45, 90 triangle, these two side lengths are going to be the same because this is an isosceles triangle. And the hypotenuse is always going to be that length times the square root of 2. Now, if you're interested in a proof on that, I'm sure you can find that out there on YouTube. I'm not going to go into the proof right now. I'd be happy to show it to you sometime. That's really more of a geometry concept. This is just meant to remind you of something you've already learned. Okay, so in a 45, 45, 90 triangle, this is how the sides are always laid out. In a 30, 60, 90 triangle, if this short leg is equal to x, then the hypotenuse is equal to double that length. And then the longer leg is equal to x times the square root of 3. And again, there is a proof for that. If you're interested, you can either go look it up or I'd be happy to show it to you sometime. But we're not going to get into that today as part of this lesson. So what we are going to try to do today is we're going to work with these special right triangles, but we want them to fit within our unit circle. And remember that I said our unit circle always has a radius of 1. So what I'm going to do is I'm going to set the hypotenuse of each of these triangles equal to 1. I don't know if you can see that super well, but I'm going to set that equal to 1, and then I want to use that to try to figure out what these x values are. So if I'm solving this with exact values, which we always want to focus on exact values here, I would divide by the square root of 2. Okay. But then I need to rationalize that denominator. I can't leave that square root on the bottom. So I would come along and I would multiply by a square root of 2 and a square root of 2. Okay. And then up on the top here, I would be left with just square root of 2. On the bottom, square root of 2 times square root of 2 makes just a 2. And that would be the value of x. Okay. So what I just showed is that if I'm setting this side equal to 1, if the length of the hypotenuse is going to be 1, these two sides are both going to be square root of 2 over 2. Okay, those orange values are what you're going to need to know for the unit circle. Okay, I just wanted to show you where they came from. So if I do the same thing with the 30, 60, 90 triangle, this one's actually a little bit easier. If I set the hypotenuse here equal to 1, just like I did before, this time solving for x is not nearly so hard. All I have to do is divide by 2. And I get that x is equal to 1/2. Okay, so again, the hypotenuse is equal to 1. This x over here we just found is equal to 1/2. And then down here on the bottom, really what I'm doing is I'm replacing this x with a 1/2. So that would end up looking like 1/2 square root of 3. The better way to write that would be square root of 3 over 2. Okay, and I realize that's kind of low. So these are the three side lengths here in orange that you need to know for the 30, 60, 90 triangle. Okay, is that if the hypotenuse is 1, the length of this side is 1/2, and the length of this side is square root of 3/2. All that math I just did right there is not math that I'm going to be expecting you to have to do during this lesson, but I'm just trying to justify for you the steps that I'm about to take on the unit circle. So what I'm going to do is I'm going to take this 30, 60, 90 triangle here, okay, with these side lengths labeled. So you see the 1, you see the 1/2, and you see the square root of 3/2. And I'm going to put that on our unit circle. Okay, so I'm going to put that right here. Okay, so again, that radius, the length from here out to the outside of the circle, has a length of 1. And then what you'll notice is the length of this side is square root of 3/2, and the length of this side is 1/2. Well, if we go back to thinking about this thing as being part of a coordinate plane, this value down here is really my x value, right? Because that's my left-right distance. And then this value here is my y value. So if I want the coordinates of this point right here, it's going to be square root of 3/2, comma, 1/2. Okay? And what I'm going to do is I'm going to label that. So notice this was a 30-degree angle that we put down here. So I'm going to put 30 degrees here next to this dot. Really, the 30-degree angle was down here, but again, just like before, I don't want to label all my angles right here. Okay? So at 30 degrees, I'm at square root of 3/2, 1/2. That's my xy coordinates. Okay? I could take that same triangle and lay it over here. Okay, I could flip it sideways like that. And I notice I still have the same lengths. Now these ones are written sideways, and that's all right. But so this length is now square root of 3/2, and this length is now 1/2. What we have to keep in mind is on the coordinate plane, if I'm going this direction, then I'm living in negative territory for my x's, right? My x's are going in the negative direction. My y's are still going positive. So I have negative square root of 3/2, comma, 1/2. Okay. Now let's talk about what to name that angle. That angle can't be 30 degrees because 30 degrees is over here. Remember, but this is a 30-degree angle down here. Remember that we're always naming our angles like from here, right? So if this is 0 degrees, what I really want to know is how many degrees is it to turn all the way around to where that line falls, okay? And I think the easier way to think about it is to think about it as starting at 180 degrees, which we know is right here, and going backwards 30 degrees. That's what's happening here is I'm at 180 and I'm going backwards by 30, okay? So 30 degrees backwards from 180 is 150. Okay. Okay. Let's do that same thing. Let's take this same 30-degree angle and put it here. Okay. Now again, when I go down here, my x length is square root of 3/2. My y length is 1/2. But this time they're both moving in the negative direction, right? This is negative on the x-axis. This is negative on the y-axis. So down here, I'm at negative square root of 3/2 and negative 1/2. And as far as naming that angle, I would probably say I'm at 180 degrees and then I'm going an extra 30 degrees to travel down to there. So 180 plus 30 is 210 degrees. And then let's see what it's going to look like when I place it over here, when I put that 30-degree angle in the center. Again, I've got an x-coordinate, square root of 3/2, y-coordinate of 1/2. My x is positive, but my y is negative. Positive square root of 3/2 and a negative 1/2 here. And to name that angle, again, I would probably think of this as 360, and then I'm going backwards by 30 degrees. So 360 backtracking by 30 would be 330 degrees. So you'll notice that these four angles are all related to each other, right? They really all have the same coordinates, but we just have to remember what happens with the positives and negatives. And that just goes based on a regular coordinate plane. We know how the coordinate plane works. We know that these are both positive. This is negative, positive. This is positive, negative, negative, and so on. Okay? Okay, so there's the first four. I'm going to stick with that same triangle I was just working with, the 30, 60, 90. But this time, instead of putting the 30-degree angle down here, I'm going to put the 60-degree angle. Okay? Think about what that's going to do here. What that should make happen is now my x value is the 1/2, and my y value is the square root of 3 over 2. So I can label this as 1/2 square root of 3 over 2. And again, that's 60 degrees. I can take my 60 degrees and put it over here, right? I still have an x value of 1/2, except it's negative. It's going in the negative direction. Y value of square root of 3 over 2 in the positive direction. So this is negative 1/2, negative square root of 3 over 2. And to name that angle, I would think of it as 180 degrees going backwards by 60, right? I'm going from 180, backtracking 60 degrees. Okay, so 180 minus 60 is 120. And I'm going to go ahead and fill that in the rest of the way around. So put my 60 degrees here. These are both negative. 80, 60 is 240. And put my 60 degrees here. This time I've got positive x, negative y. So positive 1/2, negative square root of 3 over 2. And that is 360 degrees going backwards by 60. So I would call that 300 degrees. Okay, one more set to fill in. And again, you'll notice all those ones in blue, all the coordinates are exactly the same. Your positives and negatives are just changing. Okay. Going back to the 45, 45, 90 triangle, which is here, and actually I'm going to flip it over this way to start, that goes to this middle dot, right? And we know those side lengths are both square root of 2 over 2, that the x and the y are going to be the same thing because this is isosceles. So square root of 2 over 2, square root of 2 over 2, and I would call this 45 degrees. Okay, and that's it. You've got your whole circle filled in. Now, in geometry, we made a big deal about you memorizing the entire circle and like filling it out a bunch of times. And you still technically have to have it memorized. But this year we're going to be a lot more focused on how do you use this information. Don't get me wrong, you still need to know all of this. And I know it looks overwhelming when you first look at it to think that you have to have this all memorized. But if you understand the patterns here and understand where these values came from, it's not nearly as much memorization. Really, if you can get these 3 sets of coordinates down, and again, if you know your triangles well, you shouldn't even have to memorize that. You should just know how these values turn into those coordinates. But if you can get these 3 values down, you should be able to translate those all the way around the circle, okay, as long as you know how the quadrants work as far as positives and negatives go. Okay, let me give you some hints and tips for getting this thing memorized, and then we will move on to how to actually use this thing. If you're working on just focusing on this first quadrant here, you will notice that these fractions go in order 1, 2, 3, and then 3, 2, 1 as far as the numerator goes. All of them are over 2. Technically, the ones don't get square roots, although the square root of 1 is just 1, so it wouldn't matter if you did a square root there. But you'll notice it goes 1, 2, 3 in the x's, and then 3, 2, 1 in the y's. I don't love that form of memorization, just because I think you lose sight of what those numbers really mean. But that is a good way to at least get that part nailed down. And again, if you can get those 3 set, you should be able to translate those around the circle as long as you know how the quadrants work. Okay? The other helpful advice is that if you're trying to jump from angle to angle, now we kind of filled these in as we went, but if you're trying to just fill in all the angles going all the way around, the pattern you're looking for is this jumps by 30 degrees, and then 15 degrees, 15 degrees, and another 30. 30 degrees, 15, 15, 30. So if you want to jot that down for yourself somewhere, 30, 15, 15, 30. That's the pattern that the angles fall in. Oops, sorry, can't see that. Okay, so let's talk about why these numbers are even significant. Okay, I'm going to throw one of my triangles back on here. I'll go ahead and throw the 60-degree one there. If I were to give you this triangle and I were to ask for the sine of 60 degrees, let's say, you would say, okay, well, sine is opposite over hypotenuse. So sine would be square root of 3 over 2 over a hypotenuse, but the hypotenuse is just 1. And in fact, in all of these triangles, all the way around, no matter where I put them, I could put this down here if I wanted to. The hypotenuse is always 1. So when you're putting something over 1, you don't really need to worry about that denominator. And so what that means is this square root of 3 over 2 is really the sine of 60 degrees. Okay? So this right here is the sine of 60 degrees. Let's think about the cosine. The cosine would be adjacent, which is the 1/2 over 1. And again, putting something over 1 doesn't really matter, right? So cosine of 60 degrees would be 1/2. And so what that means is that all the way around the circle, and I wrote this here, but this is true for every coordinate all the way around, your x coordinate is the cosine and your y coordinate is the sine, okay? So if I asked you for the cosine of 135 degrees, you would look at the x value and you would tell me that it's negative square root of 2 over 2. Okay, this is what we call exact values. And anytime I ask for exact values, now here's the thing. You can get the sine and cosine of 60 degrees from your calculator, right? We know that we can type those in. And you're going to get some big crazy decimals. Those are not exact because they're decimals. These values here are what I'm looking for if I ask for the exact value of cosine of 30, okay, or the exact value of sine of 225, okay? So the x and y coordinates give you the cosine and the sine of the angles. Now we're going to come back to tangent in just a minute, okay? But that's what you need to know these values for, is so that if I ask you for the cosine or the sine of an angle, that's how you're going to answer.